All right, so we are starting with section 4.3, which is rules of logarithms. Remember, a logarithm and an exponential function are inverses of one another. They like undo one another. So we have some rules for logarithms that are kind of like exponent rules. So here, when we have inside a logarithm two things being multiplied, we can split it apart with addition. What's important, though, is that this log with the base is written each time. That is called the product rule. So thinking about that, kind of like exponents, if you have a to the x times a to the y, that's a to the x times, or x plus y. So again, think about it kind of like exponent rules. For the quotient rule, when you have two things that are being divided within the same logarithm, you can split it apart using subtraction. Again, you have to keep that same log and base when you split it apart. Just like your exponent rules, a to the x over a to the y, that's equal a to the x minus y. And then we have our power rule. When we have something to a power, bless you, within a logarithm, our exponent turns into a coefficient. Similarly, if we had a to the x to the y power, that's equal to a to the x times y. So what we're doing in this section, we're going to rewrite using these rules because it will help us solve things later on to be able to use those rules. So if I have log base 5 of xz, this is like multiplication. So when we rewrite this, this is log base 5 of y plus log base 5 of z, because the multiplication meant we can split it apart using addition. And then we can replace. It says that log base 5 of y is 2. And log base 5 of z is 3. So our answer here would be 5. Questions on that one? Okay. Letter B, we have 125y to the 7th on the inside. Let's split that apart. This is like 125 times y to the 7th. So we can rewrite this. Log base 5 of 125 plus log base 5 of y to the 7th. But we can rewrite this once more. We can move this exponent to the front of this term because that's another one of those rules. Log base 5 of 125 plus 7 log base 5 of y. What questions do you have at this point? Okay. When we're talking about logarithms, you're asking yourself for something specifically like that. 5 to what power equals 125? That's how we figure out what the answer of log base 5 of 125 is. So this, again, means 5 to what power equals 125? The answer for just this part is 3, because 5 times 5 times 5 is 125, plus 7 log base 5 of y was 2. So when we add those together, we get 17. So 7 times 2 is 14, plus 3 is 17. Questions? Are you sure? Okay. An important note is that a square root is the same as an exponent of 1/2. So we can rewrite this first as log base 5 of z over y to the 1/2 power. Do you see how that's grouped together and raised to the 1/2? That means we should rewrite this portion first and put that in front. So we'll have 1/2 log base 5 of z over y. as we're expanding each of these expressions, we want to make sure that we only have one thing within the logarithm. So how would we split up something that is being divided within a logarithm? Division means we can split it by subtraction. But what's important here, you have to keep the 1/2 log base 5 in front of, oops, that's not an x, that's supposed to be a z, in front of both. So minus 1/2 log base 5 of y. Gonna move this slightly so it's not in my way. Okay, so when we do that, we're going to go ahead and plug in the values for log base 5 of z and log base 5 of y.
Please come to the office. Elliot Panas, Amit Kaur, King Lyons, and Peyton Polkan.
Is it making sense how we got those? It was given to us in the directions at the top. That's the only reason why we're able to fill those in. So 3/2 minus 2/2 is 1/2. Let's try this again with letter D. Because the exponents are on individual variables, we want to split the multiplication piece first. So we can write this as log base 5 of z to the 1/30 plus log base 5 of y to the 5th. Are we okay with that step? What happens when we have exponents? Where do they go? In front. In front of that individual logarithm. So this is 1/30 log base 5 of z plus 5 log base 5 of y. We can substitute the values. So this is 1/30 times 3 plus 5 times 2. This reduces to 1/10 plus 10. So that could be just 10 and 1/10. Questions on that top section? Okay, we're gonna try expanding that complicated stuff for A and B. I'm gonna split this in half so that we have a little bit more space to work. We'll do A on the left and B on the right. So when we have this stuff, we need to separate the multiplication from the division. Okay. What we can do first is separate the numerator from the denominator. Are we okay with that step? So log base 2, and then the whole numerator is x squared times x minus 1 to the third. And again, this was the numerator. And then we have minus log base 2 of 2x plus 1 to the fourth, and that's from your denominator. Oops. A note to remember is that anything that was in a denominator within a logarithm is always going to have this in front of the logarithm. Okay. Okay, now these two pieces are being multiplied. That multiplication is being done between them like that. Are we okay with that? Okay. So when we rewrite this first piece, this is log base 2 of x to the second. And how do we split apart multiplication? Addition. So plus log base 2 of x minus 1 to the third, and then we keep the minus log base 2 of 2x plus 1 to the fourth. Still okay? We do not have to split this apart because that's not multiplication in there. Same thing right here, that's not multiplication. It's grouped together with plus or minus in there. So we have to keep that grouped together. But what we can do is take all of our exponents, and where do we move those exponents? In front. So we move it in front of each of the individual logarithms. So this is 2 log base 2 of x plus 3 log base 2 of x minus 1 minus 4 log base 2 of 2x plus 1. That is our final answer. Oops. Okay, what questions do you have? Nothing? No? Okay. Let's try letter B then. What did we say that square root means? Yep, exponent of 1/2. So we're going to rewrite that in the very first step. We still have x to the third, y to the second, z to the fifth. But all of that is to the 1/2 power. Any ideas on what we're going to do first? Yeah, I'm going to move this outside exponent to the front first. So 1/2 log base c x to the third, y to the second, z to the fifth. Now what? Let me help you out. If I put that in there, that separates the letters from one another. How do we separate multiplication within a logarithm? Addition. So we're going to have 1/2 log base c of x to the third plus 1/2 log base c of y to the second plus 1/2 log base c of z to the fifth. Last step. What do we have to move or separate or? Any ideas? Exponents. Those exponents have to go to the front again. And when they multiply,
Andrea Miller to the office, please. Andrea Miller to the office.
it's like multiplying times the numerator. So this becomes 3/2 log base c of x plus 2/2, which is 1. Are we okay with that? 2/2 is 1. Log base c of y plus 5/2 log base c of z. How are we feeling about rewriting and expanding it all the way? Okay? Okay. Let's go ahead and move on to condensing. So it's the exact opposite of what we've been doing. We're taking this pulled apart piece and trying to put it together. So when they're separated, what does a minus sign mean? It's a fraction. So what we're going to do, we have log for both of them, and we want to group it together. The 3x is going to go on top, and the 4y is going to go on the bottom. That's it. Are we okay? Okay. For letter B, we want to move these numbers in front back up to exponents first. So ln x to the second plus ln of x squared plus 1 to the 1/2. Any ideas on what we have to do next? We could rewrite as the square root. I don't have a preference. Thank you. If you want to, you could rewrite that as a square root, but again, it doesn't matter to me if you do or don't. I'm okay with either. What else do we have to do? I just want one ln. So what does that mean? How do I get rid of this? Almost. We divided when it was a minus, so what do you think we'll do if it's a plus? Multiply. So we're going to have x to the second times the square root of x squared plus 1. Or you could have left it as ln of x squared times x squared plus 1 to the 1/2. Both would be correct. Okay? Give me the first step for letter C. Okay, let me rephrase it a little bit differently. What were the last steps when we were expanding? Because we're doing it the opposite direction of that now. Move the exponents. So here, we're gonna move the things back to exponents if they're there. Does that make sense? Okay. So this would be log base 2 of 5 to the second plus log base 2 of 9 minus log base 2 of 75. Now let's do the first two on this left-hand side. How do we combine those? What does that plus mean? Multiply. But when we do that, we have to write log only once. So log base 2 of the things that were inside being multiplied. Okay. But what does this minus sign mean? Divide. But again, only want to write log base 2 once. So this means 5 squared times 9 is over 75. The only other thing I'd want you to do is to actually simplify. 5 squared is 25. 25 divided by 75 is 1/3. 9 times 1/3 is 3. So this is log base 2 of 3. I know letter D looks super complicated. I'm going to give you your final answer, and I want you to explain to me why it's that way. Can somebody explain to me how we got that? I think this is a bit more complicated than what you'll have to do, but just in case. How to get this? Because? Yep, the addition piece meant I had to multiply these two together. Okay, how did that get down there? Yep, because it was being subtracted. And then this had to go back up to an exponent of the whole thing because the whole thing was in parentheses. Okay? When it's a 1/3, it means that the number in here is that denominator from that fraction.
Will the track and field please come to the office? Again, will the track and field please come to the office?
Okay. What's kind of cool about change of base formula, even though if you're using one of the updated graphing calculators, you can plug in whatever base you want. We can change the base and use common or natural logarithms to rewrite. What this formula up here is saying is that when we rewrite something like number 4, the base goes on the bottom. So what I mean by that, if I used a regular logarithm, I'd do log of 13 and divide that by log of 5. And that would give me the exact same answer as log base 5 of 13, which would give me the same answer as ln of 13 divided by ln of 5. This is change of base because we changed what the base of the logarithm was using the regular ones that we have within our calculators. So this is technically a log base 10 when there's nothing written. And ln means log base e. It's changing how you're using it, but it gives us the same ratio for our final answer. Questions? We're gonna skip through that. And we're gonna go straight to section 4.4, which is solving equations with exponential and logarithmic functions. So our goal, if it's exponential, get the base to the exponent alone on one side. That's our first step. What is the answer of this type of question is an exponent. I think I asked this the same way earlier this week. The answer to this type of question is an exponent. What is that type of question? Anybody sure? The answer to this type of question is an exponent. The answer of a logarithm is always an exponent. So after we get our base to our exponent alone, we want to rewrite using logarithms, and then solve. Okay? So if we look at number 1, we already have a base to an exponent alone on one side. So how would I rewrite that using logarithms? Remember, log base, I'm just going to put stuff in this spot, equals exponent. What's our base for number 1? 25. What's our exponent? Nope. X. And the stuff is 125. So if you want to, you can get out a calculator, one of the graphing calculators. As a reminder, alpha window 5 is how you get a log with a base on that calculator. Okay? So alpha window 5, you put your base as 25. What's in the parentheses is 125. What do we get for the value of x? Alpha window 5. In the bottom one, and then 25 in the bottom, and 125 in the parentheses. 1.5 is your value for x. Now number 2 looks a little weird, because we've got 2 sets of exponents. Did everybody get the 1.5? Do you understand how we got that in the calculator? Callie, you good?
Yeah, I did it wrong. I put 5.
Oh, gotcha. I was like, uh-oh, did I explain this wrong? Okay, number 2. You tell me which one you want to use as your base. I do not have a preference, and I can show you how to solve it based on whichever one you choose. So I'm going to zoom in on number 2. Which one do you want to be your base, since they both have exponents? 9 or 3? Sure. Let's go with 9. We'll say this is our base, which means x is our exponent, and this we're going to say is our stuff. Okay? I can show you both ways so that you trust me that either way works. So, log base 9 of 3 to the x plus 1 equals x. We just went over some exponent rules. What can we do to rewrite when we have an x plus 1 in our exponent? Where can that go? Yeah, we can put that in front. So we can do x plus 1, and I'm going to put that in parentheses. Log base 9 of 3 equals x. Let's figure out what the heck log base 9 of 3 is. So alpha window 5. You could also ask yourself, 9 to what power equals 3? And that would be 1/2 because it's a square root. So we have x plus 1 times 0.5 equals x. Or you could put 1/2. How many of you like working with decimals or fractions? Okay, I see no hands. Let's multiply by 2 to get rid of that, just so we have some easier stuff to work with. Are we okay with that step? You understand that multiplying by 2 will get rid of that fraction. So we're left with x plus 1 equals 2x. Now, does that look like something you can solve? Yeah. We can subtract x from both sides. So we have 1 equals x. Do you want to see it the other way as well?
Sure.
Okay. So I'm going to pick a different color just to... Okay, so 9 to the x equals 3 to the x plus 1. We'll say that that's our base, that's our exponent, and this is our stuff. Log base 3 of 9 to the x equals x plus 1. We okay with that step? With how we rewrote? Same thing as before, that x in front, or excuse me, x in the exponent means it can go in front. So x times log base 3 of 9 equals x plus 1. Log base 3 of 9 means 3 to what power equals 9? 2. So x times 2 equals x plus 1. Or you can rewrite this as 2x equals x plus 1, which looks exactly like that other step. So x equals 1. So it didn't matter which way you did it, as long as you were consistent with it, okay? Now, number 3 is quite a bit different. We've got one thing to an exponent, okay? This is what I need to get alone. What do I need to get rid of? The 5. To do that, we're going to divide by 5. But we're going to leave it as a fraction because I don't like plugging stuff into my calculator until the end, if I can help it. So we have 2 to the x minus 3 equals 17 over 5. Now that I have base, exponent, stuff, I know they're very technical terms, we can rewrite using logarithms. So tell me how to rewrite. I'll give you log. Two is our base. 17 over 5 is our stuff. Equals x minus 3. And to get x by itself, this means I'm going to have to add 3 to this. But please, 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 please make sure that you're doing 3 plus the answer of the logarithm. Do not put that 3 inside the logarithm. Does that make sense? So just make sure those parentheses are closed. So 3 plus alpha window 5, log base 2 of 17 over 5. And we're just going to estimate 4.766 is x. Questions on that one? Does it kind of make sense? Do those 3 steps at the top help as a guide of what you should do to get stuff by itself? Okay,
Can I take a picture?
absolutely. I'm also recording this,
Oh.
finally. Sorry, it's been a minute since I recorded. I'm done throwing my tantrum. Okay, I'm gonna skip that. Solving logarithmic equations. I'm gonna do my little bullet / steps. So, to solve a logarithm, first step. There's 2 options. You can either get log equals log, or log equals number. It must be one or the other. So the really important part here is you need to condense your logarithms. Okay? Step 2. This time we're going to rewrite as an exponential function. And your third step is to solve.
Can I have coffee?
You can have whatever you'd like. It might be a little cold.
Well, this one's got a name on it.
Don't worry about it. You can still take it.
Sure.
Yep. They'll figure it out. Or they won't.
I don't care if it's cold.
All right, so for number 5, let's get that logarithm by itself. Okay, so what do you think we want to get rid of first? The 4. Subtract 4 here, subtract 4 there. So 3 log base 2 of x equals -3. We okay there? But I can't rewrite yet. I need just the log base 2 of x by itself. So how do I get rid of that 3?
Add 3.
Mm?
Minus.
Try again.
Wait.
Because this is being multiplied,
Oh, divide.
divide. So we're going to divide by 3 here and here. So log base 2 of x equals -1. Now I can rewrite. You always think base, exponent, stuff. If you need to, log base of stuff equals exponent. Again, very technical terms, but you know, it helps. So what's our base? What's our exponent? -1 equals x. So 2 to the -1 is 1/2 or 0.5. I don't care if it's fractions or decimals or whatever. Got it? How do we feel about that part? Okay. Number 6. When I first look at that, what I notice is that one piece doesn't have a logarithm. So that means I need to combine these 2 together using those logarithm rules. what first draws my attention is that plus sign. For those of you that were here when we were going over those rules, what does that plus sign mean we can do when we rewrite? I can rewrite it using multiplication. So log base 2 of x minus 3 times x minus 4 equals 1. Now, was I a jerk with this one? Absolutely. You'll see what I mean by that in about 2 steps. Now that I have log of one thing equals a number, what do I have to do?
Miles Mendoza, Shia Madash, and Peter Shanakiewicz to the office, please.
I have log equals number.
Add it. Or divide it.
Mm-mm.
Multiply. Subtract.
Look at step 2.
Rewrite as an exponential.
A rewrite as an exponential. So, again, think base exponent stuff. So what's my base? What's my exponent? Equals stuff. So this is saying that 2, because 2 to the first is 2, and I'm actually going to multiply this stuff out. X squared minus 7x plus 12, because I'm a jerk. And when you get to something like this, you got to get everything on one side to solve. Minus 2. We have 0 equals x squared minus 7x plus 10. You can use factoring or quadratic formula because that's not what I'm assessing you on right now. Let's go ahead and factor it for you. You guys can struggle later. So x has to equal 5 or x has to equal 2. But only one of them is going to work. Can you tell me which one I'm going to get rid of?
The first one. Alright. X. The second power and minus 7x. Oh, or no?
So which one, only one of these will work.
Oh.
Which one do you think I should get rid of?
X minus 5 and x minus 2.
X equals 5 is the only one that works. X minus 2 does not work because when we plug it in here, and I'm actually going to write this out in words as your explanation. And I'm going to turn my thing to the side, maybe, actually no. All right, so when we plug in,
Charlie Hopitas to the office, please. Charlie Hopitas to the office.
when plugged in, we get log base 2 of negative 1 and log base 2 of negative 2. We cannot have negatives or 0 inside of our logarithm. That is the only reason it does not work. Okay? So anytime you have log of a negative or 0, can't do it. That's a big no-no. Okay? Give you a second to write that. Okay, number 7. What do you think we're going to have to do with that? Yeah, exactly. This subtraction sign means we can condense them using division. So log base 2, we have x plus 4 over x plus 3, and that's equal to 1. What's my next step? Rewrite. 2 to the first equals x plus 4 over x plus 3. Now I promise this one isn't as terrible. 2 to the first is just 2. Anybody remember how to get rid of fractions? That's to get rid of exponents. We're going to multiply by the denominator and multiply by the denominator. Essentially, it's cross-multiplying and setting them equal. So we have 2x plus 6 equals x plus 4. Now, does that look a heck of a lot nicer to work with? Yes. Subtract x. X plus 6 equals 4. Subtract 6. X equals negative 2. Uh-oh, is that allowed? Why not? When I plug it in, do I get a negative in a logarithm? No, I don't. Because negative 2 plus 4, oh, that's a positive, we're good. And negative 2 plus 3 is still a positive, so we are okay. It's okay if we get a negative as an x value, but we cannot have an overall answer in a logarithm that's 0 or negative. Do you understand the difference? Okay. Yeah, we're not going to do the logarithm scales. Forget 7.5. For these inequalities,
Miles Mendoza to the office, please. Miles Mendoza.
what we can do is actually solve this on a calculator. You would be plugging this left side into y1 and this right side into y2. I'm not actually going to make you do it right now. You don't need to. And you're going to see, where is this above that y1? And that's because, remember, the big stuff is on the wide part of your inequality. Got it? Okay. If we did this right one, this you could put in y1. The other one you can put in y2. And again, because our inequality is wide on the y2 part, you're going to look, where is this above the other one? To solve for a point of intersection, second, trace, option 5, enter, enter, enter. And the only reason I'm not explaining this a little bit better is because it's going to be somewhat of a challenge problem, not worth a lot of points on your test. Okay?
Just kidding.
Could be a lot worse. No, you weren't. And that's okay.